Okay, good morning to all. Okay, so we'll solve the problem in the next class. Okay, we'll complete the theory part. So we'll have the last topic, starting methods of induction motor. Okay, so we will start the class. It's around 9:34. Okay. So and similar to DC starters. So you already studied about the DC starters. Okay. So there is a 3 point, 2 point, 3 point, and 4 point starters. So you are familiar with that starters operation and the need or necessity of starters. Okay. So for each and every motor will have a separate starter in the case of a DC. So 2 point starter we will use for DC series motor, and 3 point starter we will prefer for shunt motor, and 4 point starter we will go for with the compound motor. Like that we discussed about the, so each and every starters will have some disadvantage and advantage, so that only we will move to the 3 point or 4 point starter. Okay, so we have some disadvantage on the 3 point, then we'll move to the 4 point. And 2 point starter is specifically used for only the for series motor alone. Okay, so the general you know. So similarly in the case of induction motor, so again we required a starting method. There is a starter is needed. So here we are having based on supply we have the two different types of induction motor. So one is single phase induction motor and three phase. So here what we are going to discuss means the starting methods we are going to discuss for the three phase induction motor. Okay. And first of all, can anyone tell that what is the need of starter? Why it is required? So as per your idea about the DC, you can tell answer. So you are not having some idea about the AC system. So as per the DC starters, so what is the need or necessity for going for a starter? So without starter, if you try to start the machine, what are the problems you will generally will face? Sanjeev Kumar, to reduce the speed. Sumant Reddy, high current will flow due to low resistance initially. Used to protect the machine. Okay, all these answers are correct almost. Okay. Mm. So any other answer? Used to protect the machine. Okay. Limit the current to reduce speed. So any other answer other than this? You can tell as per the point of series, that is a 2 point or 3 point, 4 point. It's enough. So after discussing about the AC, you will be familiar. Each and every starter will have some specific advantage and disadvantage. To limit starting current, okay, this is the exact answer. Reduce heavy sparking in the brushes. Okay, this and the to limit the starting current. Um, that is the exact answer. Okay. So as per the, what is the necessity or need for the starter means to limit the starting current. Because during the starting condition, so as per the DC machine, you will tell that back EMF will be 0. So you are having very, very low resistance in the rotor circuit. Okay. So the current will be 10 to 14, 10 to 15 times the rated current. Without starter, if you try to start the machine. So because of low resistance in the rotor circuit, so yeah, the current will be 10 to 15 times. So to limit this current, we'll add the external resistance in series with the armature resistance. Okay. So during the condition, during the starting only, this is the case. So when the motor starts its speed, gradually if the speed is increased, the back EMF will come into the picture. And what will happen? With the, will gradually remove the resistance. Thereby the current with the normal current, it will start to run. So this is the basic concept. So similarly, in the case of induction machine, so here we'll have two types of machines. One is squirrel cage, another is slip ring. So we already know. Okay. So you will know the advantage and disadvantage of the both the cases. What is the advantage of squirrel cage? What is the advantage of slip ring? And what is the disadvantage? Everything you know. So here, how you are going to start? Okay. So similar to DC series motor, for the slip ring induction motor, we have a separate starter. Okay. So what is this type of starter we'll use means we'll call that as a rotor resistance starter will be. We'll discuss what are the types. Before that, we'll discuss about. So we'll based on the HP, okay, based on the kilowatt or HP. So if the motor will in the induction motor, we have different HPs, different ratings we have. So if it is a single phase means, so the rating of the machine will be, we'll call that a single phase as a fractional horsepower. Okay, single phase induction motor we call this. This will be having less than 1 HP. Okay, the rating of the machine will be less than 1 HP. So we'll call this as a fractional horsepower machine. So in the three-phase induction motor, we have different ratings will be available. Okay. So if the rating is less than 5 HP, if the rating is greater than 5 HP, so we'll go for the different types of starters. So what are the starters used for the squirrel cage and the slip ring? So the squirrel cage, we have a stator resistance starter, auto transformer, and the third one star delta starter. So in the slip ring, we will have a rotor resistance starter. So other than that, you will have one more starter for squirrel cage will be DOL starter. So you have this classification, we'll discuss one by one. So we'll have DOL starter, direct online starter, stator resistance starter, auto transformer starter, star delta starter, and then rotor resistance starter. So based on rating, these starters you have to prefer. Okay. So before that, I will give some more idea about the need for starter. So it is used to limit the starting current, as well as it is to limit the overload. Okay. So the starter is not only used to limit the current. Okay. It will have some during the starting. It is used to limit the current. So during the running condition, so if it is overload, so the particular machine is overloaded, then we'll have a similar to OLR, overload release in the DC machine starter. Here we will have a overcurrent protection also. Okay, we'll have overcurrent protection, single phasing. So these are the some of the arrangements will be made on the three-phase system. So first, what is the operation of the starter means to limit starting current. So to limit starting current, to protect the machine from overload. And third one, single phasing. So we'll discuss one by one. So first function is to limit the starting current. This is specifically for a three-phase machine, three-phase induction motor. What is the need of or necessity of the starter? So to limit the starting current, to protect the machine from the overload. So third one, single phasing. We'll discuss one. You know what is meant to limit the starting current means? So due to low resistance in the rotor circuit, so we are going to add rotor resistance in case of DC. But in the case of AC, so the starting torque is directly proportional to supply voltage. Starting torque is directly proportional to supply voltage. How we are going to limit this starting current means, so in the stator, So in the stator, we are going to apply the three-phase supply. So rotor is already short circuited. Rotor is short circuited. So if you apply a full voltage, what will happen? So maximum current will flow in this rotor circuit because this rotor is short circuited. And if you apply a reduced voltage, then the current produced in the rotor circuit will be less. The current the short circuit current produced in the rotor circuit will be very less because this rotor current is depends upon the input supply. So as per the AC system, how will you limit the starting current? Means you won't add any external resistance in the squirrel cage. So we'll reduce only the supply voltage. We'll reduce the supply voltage means what will happen? Automatically the rotor current developed due to reduced voltage will be less. Okay. So when the rotor starts to rotate means, and you can apply gradually the voltage and you apply the full voltage, the rotor will run at a maximum speed. So this is the concept. We are going to reduce the voltage gradually and you have to increase the voltage. That way the rotor current will be limited. And second, to protect the motor from the overload. Okay. And if you apply a mechanical load, if you are beyond the rated current, if you try to load the mechanical load means what will happen? So excess amount of heat will be generated in the machine. Okay. And due to overload, what will happen? Overload means automatically it related to the current. It related to the rotor current. So this rotor current will be beyond the rated value. Then we'll have the overload protection. So it will sense the excess current and it will trip the circuit. It disconnects the main supply. And what is the third case? Means single phasing. So in the three-phase system, we'll have RYB. RYB. If one phase is suddenly not coming, we'll call that as a single phase. So if due to transformer failure or due to line failure or due to winding failure, so it may be any case. So what is the single phase means? You should need a symmetrical three-phase supply should be needed. Symmetrical three-phase supply should be needed from the input side. And due to some fault, if the one phase is not available, then the particular motor will work as a two-phase motor. Particular motor will work as a two-phase motor. It comes to the unbalanced condition. It comes to the unbalanced condition. We'll have a excess voltage and excess current will be available in this two-phase. And for that, we'll use the relay. We'll call that as a thermal overload relay. So that relay will be connected in all the three phases and it will sense. Okay. Suppose it is connected in all relay is connected in this three phase. So in this relay will not get any supply because there is no supply available in the B phase. And here we'll have a excess current. Then what will happen? The thermal overload relay will open the R and the Y phase. And you can safeguard the machine. So these are the three need for the starter. One is to limit the starting current, to protect the motor from the overload. So third will be the single phasing. So if the one phase is not available, so the three-phase motor will not run with the two-phase. Okay. During that condition, the excess current will be sensed, and that will be that will break the circuit. Okay. That is arrangement. We will discuss these protection circuits will be available in the starters. Okay. So the D-oil starter, direct online starter will be preferred for less than 5 HP machine. Or less than 5 HP, we'll prefer the D-oil starter. So beyond 5 HP, we'll go for a stator resistance or auto transformer or stall delta starter. Okay. So less than 5 HP, we'll go for the D-oil starter, direct online starter. And above 5 HP, it may be 15 HP or 10 HP, we'll go for the stator resistance or auto transformer or stall delta. And if it is a slip ring induction motor, we have only one type of starter, that is a rotor resistance starter. Okay. So first we'll discuss about the D-oil starter. And you have to write these 3 points in the case of what is the need or necessity for starter in case of three-phase induction machine. Okay. So we'll discuss one by one. So these are the things we discussed. And so in that stator resistance will not be available, you include. So these are the different types of starters available for the induction machine: direct online, star delta, auto transformer, rotor resistance starter or primary resistance starter. So one more starter is stator resistance starter. Okay. So first we will discuss about the D-volt starter. So this starter will be mainly used for less than 5 HP machines. Okay. And here we won't reduce the supply voltage. So in this case of D-volt starter, so we'll apply the full supply voltage because it is used for lesser rating, less than 5 HP. It may be used for 2 kilowatt machine or 1 kilowatt or 3 kilowatt, like that. Up to 5 we'll use this type of starter. Here we won't reduce the supply voltage. Okay. So we'll apply the full supply voltage because the rating is very less. The current generated will be 6 to 7 times only. So it will not be 10 to 15 times like that. So it will be less than 5 to 7 times only. It is for only the fraction of seconds. So this starter will have the capability to function with the full supply voltage. Okay. So here these are the arrangement available. So here we'll have a 3-phase input supply, and we'll have a fuse arrangement initially, 3-phase fuse, and this is the thermal overload relay. Okay. And next we'll have the contacts. Okay. Here we'll this is the 3-phase machine, squirrel cage machine. Okay, we have a stator and rotor. So this is the squirrel cage induction machine rotor symbol. Okay, so like this, if you draw the rotor, means it indirectly represents the squirrel cage rotor. So this small circle represents the copper bars. Okay, already you know that. So rotor is not having any windings. So the rotor will be made up of copper or aluminum bars, and both side it is welded and it is reverted. Okay, so we have a mechanically strong construction. So this is the exact symbol for the squirrel cage induction machine rotor. Okay, simplified symbol. If you ask in the question, means draw the symbolic representation of squirrel cage rotor, means you can draw this. Okay, and here we have the contacts. Okay, and here we have a magnetizing coil. So in this contact, this all are so in the it interconnected. Okay, so we have it R, Y, B supply. Then we'll have a magnetizing coil. We have a magnetizing coil, and that magnetizing coil we have 2 contacts: normally closed contact, normally open. Normally closed. So we'll call that as a stop button. So normally open contact we call as a start button. So in the starter we'll have the 2 colors. So one is green color button and another is red color. Okay. So green color is a start button. Okay. Red color push button is a stop. Okay. So this is the external. If you see the starter, means in the externally we'll have these 2 push buttons. One is green, another will be the red color. So green represents the start button, normally open contact, and red color represents the normally closed contact. Okay. That is the stop button. So so what is the arrangement? Means this coil will energize if you give the 440 volts input. Okay. So if you give for 400 volt. So you see the connection here. This magnetizing coil and these contacts are connected between 2 phases. Okay. So you consider RYB. It is connected between Y phase and B phase. Okay. B phase you will have, and you will have a normally open contact, and this end is connected to here. And the output of the normally open contact will be connected to the normally closed, and we will have a closed circuit with the magnetizing coil. Okay. So this is the starting. It will go like this, the connection, and it will goes to the magnetizing coil, and it will goes to the another supply. Okay. Okay. This is the case generally. So are you clear with this connection? Connection either doubt இருக்கா? Okay, so you see here we will have the 2-phase supply. So here this is Y and B. So in between Y and B we are connected this magnetizing coil and these 2 contacts. So normally open and normally close. Okay. And if you are trying to start this, if you are going to start this starter, okay, we are applied the full supply voltage. The full supply voltage will be available at this contact. So if you apply the three-phase input, the R, Y, here we'll have the supply R, Y, B. We'll have the input supply will be directly coming to the input side of the contact. Okay. Then if you push this button, normally open contact, if you try to start, so this is a push button. If you press means it will temporarily short circuit these two contact. It will temporarily short circuit these two contact, and it will comes to original position. Because it is a push button, it will temporarily connect. Okay. And if you press means what will happen? It will short circuit. So that's the two-phase supply will go into this coil. So this coil will get energized. This coil will get energized. So once it gets energized, what will happen means, if it is energized means, it will pull this arm. Okay, it will pull the arm towards the right side. It will pull the arm towards the right side. What will happen? These contacts will get closed. Okay, all these contacts will get closed. Okay. If it is closed, all these four terminals are gets supply means what will happen means full supply voltage will be given to the stator, and this is open circuit. Then through these, so these normally closed contacts through this winding. Okay, so what will happen? This will be in closed condition. This will be once it gets energized, it will be released. Okay. And if you want to stop this means what will happen? If we close this this way, if we open this normally closed contact, if we press means what will happen? It will de-energize this magnetizing coil. So this start button is used to energize the magnetizing coil. This stop button is used to de-energize the magnetizing coil. So based on this magnetizing coil only, so these contacts will be moved right side or left side. Okay. Once this magnetizing coil is energized, so it will pull this entire arm and it will close the three-phase supply. Okay, and the full supply voltage will be given to the stator circuit. So once if you pull the push the stop button means what will happen? So it will de-energize this magnetizing coil and it will release the arm towards the left side. So if it is moving towards the left side means what will happen? So you are breaking the input supply. Okay. This is as per the operation. What is the role of a start button and stop button? So start button is used to energize the magnetizing coil. Stop button is used to de-energize the magnetizing coil. So based on the magnetizing coil condition, so the entire contacts will move right side or left side. If it move right side means it will close the supply. Supply will be given to the stator. And if we move towards the left side means what will happen? It will disconnect the supply. So this is the operation. Okay. So here we are not going to limit the voltage. So once if we start means, then full supply voltage will be available across the stator circuit because it is having lesser rating. So the amount of current produced in this D-volt starter can be withstand by the induction machine. Okay. This is as per the starting condition. Okay. So if you are trying to overload this machine, so what will happen here? We have already I told that there is the need for single phasing. So here we have in the all the phases. So we are having thermal overload relay. We have a thermal overload relay. So if you are applying a mechanical load in the machine, then what will happen? The excess current will be taken from the supply. So in all the phases, so due to overload, we have the excess current will be taken from the supply. Then what will happen? This thermal overload relay will start to melt. Okay, it is based on the temperature. If the excess current is moving means it is made up of a bimetallic strip. Okay, so the bimetallic strip is going to bend based on the flow of current. If during normal condition, so there will not be any physical change in the bimetallic strip. So once the temperature increases due to excess current, so what will happen? Gradually the bimetallic strip will start to bend and it will disconnect the circuit. Okay, it will disconnect the circuit during overload as well as during single phasing. So single phasing means one phase will not get supply. So remaining two phases will receive the supply. Okay, so then also we'll have here, if a three-phase motor is working as a two-phase motor, there will be excess flow of current will be available in the remaining two phases, again the bimetallic strip will start to bend. Okay, so it has the property that if excess current is available means it will start to bend. Okay, and if you disconnect this circuit, okay, if you bend means it will open the circuit. Okay, then when the temperature reduced in the bimetallic strip means it will comes to the original position. It will comes to the closed condition. So this is the property of the thermal overload relay. Okay, are you clear up to this? Are you clear with the operation? So what is the need of D-volt starter? The D-volt starter will not reduce the input supply voltage. Full supply voltage will be given. Okay, so you have to explain all these things. Are you clear? Are you having any doubt? Shall we move into the equation for this starter? We have a small equation. Let doubt irukappa. So I will tell the key points about the D-volt starter. So it is not, it will not reduce any supply voltage. It will give the full supply voltage. So this type of starter will be used for less than 5 HP induction motors. Okay. And if we give this full supply voltage, what will happen means, so they will have a magnetizing coil, normal start button, stop button. So the magnetizing coil will be connected to the two phases. So to energize it needs almost greater than 440 volt. Sorry, 400 volt. Okay. So this is the initial position of the switches. So normally open is a start and normally close is a stop. Okay. So when you when you press the start button, the magnetizing coil will energize and it will pull the contact towards the right side. So full supply voltage will be given to the stator segment. And if you try to off this machine means in the normally closed if you press the stop button, the magnetizing coil will get de-energized and it will release the contact. If it release the contact means what will happen? It will move towards the left side and it will break the circuit. Okay. So if there is any overload is available, then or single phasing is available, the thermal overload relay will protect both the single phasing as well as the overload condition. These are the key points about the D-volt starter. Okay. So next we'll have a small derivation. So you write, I will explain. So that is the relationship between the starting torque and the full load torque. So you can take the topic D-volt starter. So write these equations while we solve the problems. These equations will be needed. So take down, I will explain finally. So as per the DOL starter, so we'll have the rotor input. Okay. So rotor input, notation for the rotor input will be P2. So we can give that as a 2 pi ns into t. Okay, 2 pi nt. General will tell that. So 2 pi nt by 60. Okay. So this we are considering as ns. Okay, ba? So 2 pi ns into t. So this we are given as a kt. So we'll give that as equation number 1. And rotor copper loss Pc is equal to S into rotor input. இதெல்லாம் derive பண்ணிருப்போம் நம்ம. So Pc equal to Pcu equal to S into, so rotor input on the P2. Okay. So from this we are writing this equation 3 I square R equal to S into Kt. Okay. So rotor input. Okay. And from this we consider this 3 R2 we are going to consider as a constant. So R2 constant means this 3 will be constant. So K will be constant. So what are the remaining parameter available? Torque. Torque will be directly proportional to I2 squared divided by S. Okay. We are considering R2 as a constant and 3 as a constant, K as a constant. So torque will be directly proportional to I2 squared by S. So from this equation, we can write I2 will be directly proportional to I1. So based on I1 only, I2 is going to be produced. So we are replacing this equation as the torque is directly proportional to I1 squared divided by slip, or it can be given equate in terms of constant K I1 squared by S. Okay, from this equation. So at the starting, S will be equal to 1. Okay, so slip value will be, because n is equal to 0 means what will happen to the slip value? Slip will be equal to 1 only. Okay, so the starting torque will be directly proportional to I1 squared from this equation. Okay, to apply S equal to 1. So we'll get the starting torque. We are replacing T as a T starting. This is directly proportional to I1 squared. And if we equate it again, you will get constant into IST squared. Okay, starting torque, starting current. We are bringing as like this. Starting torque equal to K into I starting squared. So IST is the starting torque and IF is the full load. That is the starting current, full load slip. So if you represent F, that is full load. ST represents the starting. Okay. And with reference to the previous equation, you can give the full load torque will be equal to KIF squared divided by SF. So from this equation, so instead of I1, instead of S, we are replacing the torque equation as a T full load equal to KIF squared divided by SF. And if we take the ratio between the starting torque and the full load torque, okay. So if this is the starting torque equation, and the full load torque is this equation. If we take the ratio between the starting torque to full load torque, then you will get IST divided by IF whole square into SF. And again, we are replacing this starting current as a short circuit current. Okay, this starting current will be almost equal to the short circuit current. So we are replacing this. What is the final expression for the DOL starter means? So starting torque to full load torque will be equal to, so ISC divided by IF whole square into SF. So this is the final expression, the ratio between the starting torque to full load torque for a DOL starter. And here you have to remember the condition. So we are not reducing any voltage here. We are applying the full voltage. So these two currents will be almost same only. We will not have any ratio. Okay. So starting current will be equal to short circuit current. Doubt equation. So this is the final equation for the DOL starter. So the ratio between the starting torque to full load torque. ஏதாவது டவுட் இருக்கா? கிளியரா இருக்க போர்ட்ல ஏதாவது நோட்டேஷன் புரியலாம் கேளு. Shall we move to the no doubt put Ashwin? Okay. Shall we move to the next type of starter? So not having any doubt on this keyword. So it is an important 10 mark or 12 mark question. Okay. You will have a 2 mark also. The 2 mark, what is the need or necessity for 3-phase induction motor starter? What are the different list the different types of starter for a squirrel cage induction motor? Write the starter name for slip ring induction motor. So we will have these questions. Okay. So we'll move to the next type of starter. So rotor resistance will finally we'll discuss. Okay. We'll move to the stator resistance, full stator resistance starter. Okay. Then afterwards we'll discuss about the auto transformer. So what are the advantage? சொல்லுப்பா.
நாகராஜன், இந்த வாய்ஸ் மட்டும் கொஞ்சம் மாறி மாறி வருது சார்.
வாய்ஸ் மாறி மாறி வருதுன்னா போர்டுக்கு போனா கொஞ்சம் கம்மியா இருக்கும்னு நினைக்கிறேன்.
அது ஒரு மாதிரி கிணத்துக்குள்ள இருந்து பேசுற மாதிரி அந்த மாதிரி ஒரு டிஃபரன்ஸ் வரும்.
அப்படியா?
கொஞ்சம் மைக் மட்டும் கரெக்டா ஆச்சு.
மைக் இல்ல, இது ப்ளூடூத் மைக் தானே இது.
ஓகே, ப்ளூடூத்ல இருக்க மைக் அந்த
இல்ல இப்ப கேக்குதா கிளியரா?
ஓகே சார்.
இப்போ இப்பயும் அப்படிதான் கேக்குதா? இப்போ நல்லா கேக்குதா?
ஓகே சார், நான் ஹெட்ஃபோன் போட்டு பேசுறேன், அதனால எனக்கு கிளியரா கேக்குது. பசங்களுக்கு எப்படி இருக்குன்னு தெரியல.
தம்பி உங்களுக்கு எல்லாம் கிளியரா இருக்கா? உங்களுக்கு வாய்ஸ் கம்மியா இருக்காப்பா?
சார் இல்ல சார், லோவா இருக்கு வாய்ஸ்.
இப்ப 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 எப்படி இருக்கு? இப்பயும் லோவா இருக்கா?
எஸ் சார்.
ஓகே ஓகே, அதான் என்னன்னு செக் பண்ணிடுறேன். அப்படின்னா 1 செகண்ட். இப்ப இப்ப நல்லா கேக்குதுங்களா? ஒருவேளை சார்ஜ் கம்மியா இருக்குன்னு நினைக்கிறேன். சரி, அதனால ஹெட்போனே போட்டேன். ஓகே சார், ஓகே. ஸோ நெக்ஸ்ட் யூ டேக் த டைப் ஆஃப் ஸ்டார்டர், ஸ்டேட்டர் ரெசிஸ்டன்ஸ் ஸ்டார்டர். So this is the diagram for the stator resistance starter. Okay, you can see the board. So this is the arrangement for the stator resistance starter. Okay. So we'll have in the stator side, we are going to connect here three resistance in series for R phase, R, Y, B. So you can connect here three phase rheostat you can connect, or three phase resistance will be connected in series with the stator. Okay. And there is no external input given to the rotor circuit. You are not supposed to connect anything on the rotor side. Okay. So in the stator, we are connecting the resistance in series with the stator winding. Okay, RYB. Here we are going to apply the three-phase supply. We'll have a TPST switch. This is the run position. This is the start position. So what is the start position? You will apply. You will include all the resistance available in the circuit. Okay. Full resistance will include in series with the stator winding. Okay. So thereby what will happen? You will limit the current. Okay. And if you want to increase the speed of the rotor, means what will happen? You will gradually reduce the resistance, and you will remove the entire resistance from the stator circuits once the motor attains the rated speed. Okay, you know the speed. So the speed is going to be start from the 0 to n. Okay, the rotor speed is going to be from 0 to n. It is going to be varied. Okay, so during the starting condition, the position of this variable terminal will be at the maximum resistance condition. So it will include the entire resistance in the stator circuit. Okay, and gradually will through the variac will remove the resistance from the stator circuit gradually, and it will then finally when the motor attains the rated speed, so will it represents that you are removed full resistance from the stator circuit. Okay, and here we are going to include the term X. Okay, so in the previous D-volt starter, we applied the full supply voltage. So this X is absent in the case of D-volt starter. In D-volt starter, this X will not be available. Why means in D-volt starter, we are applying the full supply voltage. So the D-volt starter will not restrict the input current. It will, what is the current available in the taken by the motor, it will allow the entire current. Okay, and it is used for low rating. So the current will be, the amount of current or 6 to 7 times of the current will be withstand by the machine. Okay, But in the stator resistance starter, we are using this type of starter above 5 HP. Okay, above 5 HP, we'll go for the stator resistance starter. So what will happen? This X, what is the X means? Fraction of voltage reduced due to stator resistance. Okay, this X represents indirectly what is the amount of resistance you are going to include in the stator winding. Okay, that is the X value. So in the case of D-volt starter, starting current will be equal to short circuit current in the D-volt starter. But in the case of stator resistance starter, starting current will be equal to X into short circuit current. This X represents what is the amount of resistance you are going to include. Okay. So based on that, the voltage or current will be decided. It will be allowed. Okay. So we will include this X as a parameter, and we are writing starting torque with respect to that equation. Starting torque equal to square of the voltage. You will tell. Okay. So voltage square. So into that value. Okay. So here we are considering in terms of square, because starting torque is directly proportional to square of the voltage in this equation. So we are replacing this equation as starting torque is equal to X squared into short circuit torque. Okay. And here if we are coming to here, starting torque to full load torque. Okay. So we'll include we'll have only this additional parameter. Remaining equations will be almost the same. So this is the general equation we are having as per the D-volt starter. So in the D-volt starter, we derived this expression. Starting torque to full load torque equal to starting current divided by full load current whole squared into full load slip. Okay. Here, what is the small changes? We are going to have these small changes only. So in this here, in the case of D-volt starter, this will be the final equation. Okay. So stator resistance starter will have this expression. So you substitute in the place of starting current, you substitute this value. So X into short circuit current. Okay. And you take this X outside. So we have X squared. So short circuit current divided by full load current whole squared into full load slip. And this will be absent in the case of D-volt starter. So stator resistance, we are including this parameter X squared. So that is the amount of resistance we are going to include in the stator circuit. So what is the advantage of this? Why you are coming for this type of starter means? What is the advantage? This type of starter can be used for greater than 5 HP. Okay, greater than 5 HP, you can go for the first type of starter as a stator resistance starter. Okay, and this type of starter will be less expensive. Okay. So high power factor during starting condition. These are the some of the advantages. Okay. What are the advantages means? The cost of the starter will be very less. Okay. We'll have a high power factor during starting condition. And this type of starter will be preferred for greater than 5 HP machines. And what are the disadvantages of this type of starter means? So due to resistors we are using, so more amount of heat will be generated. Okay, more amount of heat will be generated in this machine. Okay. And the low torque efficiency. So we'll have a low torque efficiency. So we'll move to the next type of starter, is the auto transformer starter. So as per the construction, it will be simple. Okay, it will be cheap. Okay, and it can be used for the more than 5 kilowatt or more than 5 HP. And what is the disadvantage means? So due to presence of resistance, more amount of heat will be dissipated from the starter. Okay, and we will have a low torque efficiency. So these are the disadvantages. To overcome this, we'll move to the auto transformer starter. So here you remember that relationship between the starting current and the short circuit current. That is important. You will have a only small change in that equation only. So remaining equations will be similar for all the type of starter. Okay. So that the X is going to be changed. In first case, X will be absent. Here we are included the X. Then we will discuss about auto transformer. Okay. So where generally have you seen this type of starter anywhere? Auto transformer starter. இங்க பாத்துறீங்களா? Auto transformer நீ லேப் பண்ணாதனால தெரியாதுன்னு நினைக்கிறேன். So this is the simplified arrangement of the auto transformer starter. You will have one more circuit. You see this circuit first of all. So mainly the starter is used to reduce the voltage, that you remember. So like this only we are going to connect. So we'll have a induction motor, that is a star connected winding. Okay. Auto transformer, it is also star connected. Okay. So the auto transformer will have a variac. So auto transformer will generally, what is the role of the auto transformer? So this auto transformer is used to give the variable input voltage. Okay. So it can vary from 0 to maximum value. Okay. So based on the position of the variac, the voltage will be fed to the induction motor. Okay. So we'll see the next diagram. So this is the actual auto transformer starter diagram. So in the right side, we'll have this entire circuit is an induction motor. Okay. So we'll have a 3-phase winding, and then we'll have a, this is stator winding, this is a squirrel cage rotor. Okay. This is the actual arrangement of the starter. So we'll have how many terminals will be available in the stator means we'll have 6 terminals. Okay, that is you will represent as instead of 1 1 dash A1 A2 B1 B2 C1 C2, like that we will tell. Here it is represented as a 1 1 dash 2 2 dash 3 3 dash. So we consider 1 as a R phase, 2 as a B phase, Y phase, 3 as a B phase. Okay, and here you see how many contacts are available. We'll have 6 contacts. Because here we are having a 6 winding, 6 terminals are available. 6 terminals are available, so we'll have the 1 to 6. And in 1 3 5 we'll have the winding. At the terminals 1 3 5 we'll have the windings. Odd numbers, even numbers will have the variac. So 1 3 5 is a fixed winding available, and 2 4 6 will have a variac. See, this variac will vary uniformly in all the phases. Okay. And in the lower side, 1 1 dash is short circuited, 2 2 dash short circuited, 3 3 short circuited. That is 1 and 2 is short circuited, 3 and 4 is short circuited, 5 and 6 is short circuited. Okay. And the upper position, if you have the switch is connected to the upper side, it is start position. And if it is connected to the lower side, we call this as a run position. Okay. And if this is the actual connection diagram. Okay. So if the switch, this switch is present towards the upper side, 1 1 is connected, 2 2 is connected, 3 3 is connected, 4 4 is connected, 5 5 is connected, 6 is connected means, so this is start position. And this, if you change the switch position from upper to lower side, okay, then we'll call this as a run position. Okay. And if we suppose, if we consider during the normal condition, it will be in the upper side only. It will be in the upper side only. So if we give the 3-phase supply, input is given. So what will happen means, so all these terminals are connected, and from which terminal the stator receives supply, in the odd terminal or even terminal. So stator receives supply from the odd numbers or even number. You can see the diagram and you can post the answer. Stator winding will receive the supply or input from the odd numbers or even numbers. Will receive the supply from 1 3 5 or 2 4 6. Supply வந்து எதுல இருந்து போகும்னு கேக்குது. If we keep the position like this, as per the diagram, if we are keeping the position on the upper side, the supply will go to the stator winding through odd numbers or even number. How will it will close? The even number. Okay, it will enter into the odd number and it will leave towards the even number. That is the position. Okay, okay, correct. Correct. Ruban, Meenakshi Sundaram, Hariharan, Avinash. So from the input, it will enter to the odd number. So entire winding will receive the supply. Okay. So 135, entire winding will receive the input supply. So the output of the winding will be given to the even number. From 246, it will be applied to the stator winding. So if you adjust the variac, you can vary the input supply voltage. Full supply voltage will be available in the winding. Full supply voltage, entire supply voltage will be available in the windings. Okay. So based on your requirement, you can change the variac and you can variable voltage can be applied to the stator. So this is the concept. Okay. So once you close the TPST switch, full supply voltage will be fed to the winding. So in the winding, full voltage will be available. And based on the position of the variac, the ratio, the number of voltages will be reduced based on the number of turns. Okay. And that will be given to the stator winding. Okay, this is the case. So during the starting condition, so you are going to adjust the auto transformer, thereby you are going to limit the voltage. And once the motor attains its speed, what will happen? You will change the position of the switch towards run position. If you change the position of the switches from start to run, what will happen? Full supply voltage will be given to the stator winding. Full supply voltage will be, so from 1, it is directly given, there is no winding connected during running position. Simply if you change the switch from start position to run position, so what is the supply voltage available? That will be fully fed to the stator winding. So once the motor attains 70 to 80% of the rated speed, the position of the switch will be changed from start position to run position. Very clear? And full supply voltage will be given to the stator winding. So we will get a maximum torque. We will get the maximum torque will be obtained during the running condition. So this is the concept of the auto transformer starter. So this you have to explain. First you have to explain about the construction, how it is connected. So during starting, what are the terminals available? During starting condition, full windings will be included or illaya அப்படின்றத explain பண்ணும். So generally if we consider auto transformer, so based on the number of turns, only the supply voltage will be given. So we'll have a changeover switch. So if by using the changeover switch, once the motor speed is attained to 80%, then you will put in the run condition. So full supply voltage will be given. Okay. And next coming to this equation, so already we are included this x. You know what is by x? That is the x is the number of turns you are going to include. There number of resistance value you are going to include. What is the amount of resistance here? What is the amount of reactance you are going to include? That is in terms of resistance. Here it is in terms of reactance. So you can represent this x value like this also. So this x. So x is equal to starting current. That is the supply to the motor current. So input supply la evlo current irukku, motor ku evlo supply பண்றீங்க. Limit பண்ணி தான் நம்ம supply பண்ணுவோம். That is the x value ratio. So when this x value, when the starting current supply current is equal to motor current means if you apply the full voltage, then these two will be equal. But during the starting condition, so starting current will be more in the supply side compared to the motor current. Okay, so you can write this equation like this: I starting supply equal to x into starting current of the motor. Okay, so அதுதான் அங்க IAC ன்னு கடைசியா மாத்துவோம். So I starting supply equal to x. What is this I starting? So this is x into motor current. Okay, and here we are representing this I starting is equal to, as per that equation, x into ISC. X into ISC. You can see the board. ISC equal to x into ISC. So you substitute here, you will get x squared ISC. x squared. So the ratio will be almost same only. The stator resistance starter and auto transformer starter, the starting torque to full load torque equation will be almost the same only. So the x you have to differentiate that x in the case of stator resistance, it will be x value will be in terms of resistance value. Here x value will be in terms of reactance value. That's all. Remaining concept will be same. There will not be major changes. So we will have this x squared into ISC, and then we are taking the ratio between the starting to full load. So we will have this x squared into short circuit current divided by full load whole squared into SF. So here this x is with respect to reactance value. In case of stator resistance, x will be related to the resistance value. So what is the advantage of this starter? This starter is also preferred for more than 5 kilowatt induction machine. And compared to stator resistance starter, this starter will have power loss will be less. Power loss will be less. Okay. And it will be expensive compared to stator resistance starter. Advantage is power loss will be less. And this auto transformer starter can be used both for star and delta connected motors. You can use both for star and delta connected motor. Power loss will be very less compared to stator resistance starter. And what is the disadvantage? It will be more expensive than stator resistance starter. It will be more expensive because there we are using resistance. Here we are using reactance. That is a winding. Are you clear? This auto transformer. Shall we move to the next topic? For stator resistance and auto transformer, the torque equation will remain same. It will be almost the same. What is the difference? You got to represent. X will be in terms of resistance or reactance. Shall we move to the star delta starter? Auto transformer doubt irukka? Okay, no doubt. Okay. So these are the some of the advantages. Okay. Smooth starting, acceleration, reduced line current. You will omit the third point. So cost will be high. Okay. So then we move to the star delta starter. So what is the need to go for this star delta starter? Already auto transformer starter is available. So what is the need to go for star delta starter? In order to reduce the cost. Okay. Because the auto transformer starter will be bulky and it will be costly. Okay. Generally, if you use the inductor, then what will happen? The circuit will be bulky. It will be have more weight. Okay. You may have some advantages, smooth starting, so reduces line current, acceleration will be better. Okay. High acceleration, that and all okay. But compared to the cost, it will be have more higher cost, and it will occupy more space, and it will be bulky. So in order to avoid this, we'll move to the star delta starter. Okay. And here you see, so how we are going to start means here. So here we will have again we'll have the TPST triple pole double throw switch. So we'll have it will during starting condition. It will start as a star connection. So during running condition, it will be connected as a delta. You see the stator winding. So there will not be anything, you cannot do anything on the rotor side. Already I told in squirrel cage induction motor, you cannot do anything on rotor side. Everything you can do only on the stator side. So what is this concept means? So here we'll have three phase winding separately, 1 dash, 2 dash, 3 dash. Okay. And you see the position of the switches, three phase supply is given, full supply is given to the winding. So what is the positions the supply is given at the entry point is 1, 2, 3. That is the entry point. Leaving point is will be 1 dash, 2 dash, 3 dash. So input will enter through 1, 2, 3, and it will go out in 1 dash, 2 dash, and 3 dash. So 1 dash, 2 dash, 3 dash is connected at the TPDT switch. Okay, TPDT switch la வந்து connect பண்ணியாச்சு 1 dash, 2 dash, and 3 dash. So during the starting condition, the stator winding will be star connected. So during the running condition, if you change over the switch towards the upper side, then that is the run condition. The stator winding will be delta connected. So during starting condition, it will start as a star connection. During running condition, it will be converted as a delta connected. So why you are doing like this means you will have the relationship between the line voltage and phase voltage. Okay. So for the star and delta, you will have the relationship between the star connected. So what is the relationship between the phase voltage and line voltage? So phase voltage will be line voltage divided by root 3, and the current will be same. Current will be same. You can refer the relationship between the star and the delta connection. So we'll have the line voltage is equal to phase voltage equal to line voltage divided by root 3, and the IL is equal to I phase. So this is the relationship in the case of star connection. So in the delta connection, phase voltage or line voltage will be equal to phase voltage, but the current will be reduced. Phase current will be reduced IL divided by root 3. Okay. So during the starting condition, we are reducing the supply voltage by root 3 times. What is the percentage we are, that X value? X னு ஒன்று போட்டிருப்போம் பாருங்க, அந்த X தான் ratio. So what is the X value here? That is 1 by root 3. That is the ratio we are changing. That is the ratio we are reducing the input voltage. Okay. And during running condition, we are going to apply full voltage to the stator. This is the role of the star delta starter. Okay. So if we connect at the star position, so the winding will be star connected. Okay. So what is this? Condition, if you consider, if you put the star connected, the 3, 1 dash, 2 dash are short circuited. Okay. If you see here, so this if you connect this 3 terminals, what will happen? 3, 1 dash, 2 dash are short circuited. Short circuit panamna now you will have a common point neutral. That is considered as a neutral point. Okay, it is connected as a star connector. And if you put at the upper side, connect on the upper side, and to connect like this, then what will happen? It will be connected in the delta. So you see here 1. The 1 la வந்து என்ன இருக்கும்? இந்த 1 connect பண்ணிடுவோம். So 1 dash எங்க போய் connect ஆகுது பாருங்க. 1 dash so will be connected at 2. And next, if you see the next terminal, 2 dash will be connected at 3. Okay. So like that, we will have a closed path. We will have a closed path. So in the star connection, this 1 dash, 2 dash will get short circuited, and it will have a single point as a star. So in the run condition, we will have the delta connection. Okay. So what is the parameter? We are reducing the voltage means ratio is 1 by root 3. So that is the difference between the auto transformer starter and star delta starter. So here in the final equation, what you have to include means in the place of X value, you are supposed to include 1 by root 3. The remaining things will be same. So I will write the equation so you can copy for the star delta starter. You know this V phase equal to VL by root 3. So this are you are familiar. And next I phase equal to IL, that is equal to VL divided by root 3 into impedance Z phase. And this is as per the star connection. So if it is moving to the delta connection, so IL is equal to EL divided by ZP into root 3, where V phase equal to VL and IL equal to root 3 into I phase. So generally write the star relationship and the delta relationship. So first is this is for star and this for delta. And here the starting torque to full load torque. So will be given as from this equation, general equation. So in this is the general equation, x squared into IAC divided by IFL whole squared into S. So where x equal to 1 by root 3. So here we have that is a 1 by 3 into IAC divided by IFL whole squared into SF. And during switching, so you can write starting to full load also you can write. So what is the starting equation? VL divided by root 3 into ZP. So into running, you can write ZP divided by VL into root 3. So if you cancel means you will get 1 by 3. So you cancel the common terms means. So this is during the starting condition. This is during the running condition. So this is star connected and this is during the delta connected equation. So if we take the ratio, so we will get to 1 by 3. So that ratio only here we are representing as 1 by 3. So this is a small difference in the case of star delta starter. So instead of x squared, we are replacing the parameter as 1 by root 3. So what is that 1 by root 3? That is the relationship between the line voltage and phase voltage in the case of star connection. Okay. So during the starting condition, we will have the parameter of 1 by root 3. It will be the voltage will be reduced in the terms of 1 by root 3. During the running condition, full voltage will be supplied to the starter circuit. Okay. And in the final equation, we will get that the starting torque to full load torque equal to 1 by 3 into IAC by IFL whole squared into S. So what is the advantages of this starter means? So in almost all the in all three-phase induction motor, so we will prefer this star delta starter only. Why means? So it will not have any maintenance, maintenance-free operation. Cheapest starter of all. If you are having So consider all different types of starter, DOL or auto transformer or stator resistance or rotor resistance. So this starter will be having maintenance almost zero. Maintenance will be very minimum. So this the cost of the starter will be very less. Okay, it will be cheap. And what is the disadvantage means you can vary the voltage only by the ratio 1 by root 3. Okay, you can reduce the voltage by 1 by root 3 only. So other ratio it cannot be possible. Okay, if we consider auto transformer starter, so we can have any ratio or any change in any amount of voltage can be applied because we are having a variac. So fractional voltage can also be applied to the stator circuit. We are not having any fixed ratio. But in the case of star delta starter, we are having a fixed change in voltage only. So during the starting period, the voltage will be reduced by 1 by root 3. Okay. So during running period, it will be applied as a full voltage. That's all. We have only two change in voltage only in the case of star delta starter. But in the case of auto transformer starter, what will happen? You can have a fractional change in voltage also can be possible on the stator side. That is the main disadvantage of the star delta starter. So advantage, I will tell one more time. So maintenance free operation or maintenance will be almost zero. The cost of the starter will be very less compared to other starters. So hence it is commonly used in all the types of three-phase induction motors. So are you clear up to this? So we discussed the four types of starter. So these four types of starter is used for squirrel cage induction motor only. It will not be used in the case of slip ring induction motor. Direct online starter, stator resistance starter, auto transformer starter, D-volt starter. Okay. And here you have to remember the diagram and the expression. It is a very important. So while explaining, you can explain the concept. But during the valuation, we will see only the diagram, correctness and equation. And what is the equation means the relationship between the starting current and the short circuit current. And the ratio, what is the change in ratio? Okay, that final expression will consider. And then you have to write some points related to advantage and disadvantage. Okay. So you may have 2 or 3 points, at least 2 points you are supposed to write. So in the D-volt starter, you can have this or equation வச்சு எல்லா equation நம்ம consider பண்ணிக்கலாம். ஓகேவா? Stator resistance starter அப்படின்னா we'll have that x value. D-volt starterனா x எந்த ரேஷியோமே இருக்காது. We'll have starting torque to full load torque equal to short circuit current to full load current into slip னு வந்துரும். ஓகேவா? So in the case of stator resistance starter, so we'll have that x squared. Auto transformer starter and stator resistance starter will be more or less we will have the same expression. So in the star delta starter we'll have include instead of x squared we'll have 1 by root 3. Are you clear? Are doubt irukka? Are you clear with these four starters? Clear. Okay. Okay, well, next class we'll discuss about rotor resistance starter and the soft starting of induction motor. Okay. So rotor resistance is generally used for the slip ring induction motor. Okay, that we will discuss. And what is the soft starter? Are you having any idea? Soft starter or solid state drives. So it represents that you are not going to have any moving contact. So here in this starter we are having some moving contact. Moving contact is one variac on the moving contact. Then TPDT switch on the moving contact. So if you want to change over the position, then we'll have some interruption. So this will be avoided in the case of solid state drives. That is the advanced types of starter using Powertronic device. So these two topics are available in the case of module 2. இது ரெண்டும் தான் நம்ம டிஸ்கஸ் பண்ணோம். So in next class we'll discuss about rotor resistance starter and solid state starters. And then we'll continue with solving the problem in the module 2. So we have to solve the problems on the torque equations and power stages and the starters. The starters la paathukolingla different types of starters. So in this we are supposed to solve some problems. And the speed control la we'll discuss in the module 3. So here you have to remember what is the need for starting. Yeah, what is the need for starting? That is important 2 mark question. அது எக்ஸ்பிளைன் பண்ணோம். ஸ்டார்டர் எதுக்கு தேவை அப்படின்னு சொல்லியிருக்கேன். 3 பாயிண்ட் அதை 3 பாயிண்ட்ஸ் இருக்க மாதிரி பார்த்துங்க. டு லிமிட் ஸ்டார்டிங் கரண்ட், டு அவாய்ட் சிங்கிள் ஃபேஸிங், டு ஓவர் கம் ஓவர்லோடிங். ஓகே, டு அவாய்ட் ஓவர்லோடிங், ஸோ வில் கோ ஃபார் த ஸ்டார்டர்ஸ். ஓகே, அண்ட் தென் பேஸ்ட் ஆன் டைப்ஸ் ஆஃப் ஸ்டார்டர்ஸ் ஃப்ரம் ஸ்டேட்டர் சைடுன்னு கேட்பாங்க இன்டைரக்டா. எக்ஸ்பிளைன் த ஸ்டார்டர்ஸ் ரிலேட்டட் டு ஸ்டேட்டர் சைடு. Explain the starters related to rotor side. Okay, so stator side, how will you control the voltage? Now you have to explain this. In the DOL, we are not going to control any voltage. You have to explain remaining 3 starters: star delta, rotor resistance, star delta, auto transformer, stator resistance. So by using these 3 starters, we are going to vary the voltage from stator side. Then from rotor side, how we are going to change the voltage means we have to write about rotor resistance starter. Okay, and separately, if you are asking, explain the types of starters used below less than or less than 5 HP. Explain the starter used below 5 HP means you have to explain about DOL starter. Okay, above 5 HP means you can have all the other types of starters. Above 5 HP na you can discuss about the rotor resistance, auto transformer, stator resistance, star delta, everything you can explain. Okay. So that's all about today's class. Okay, we'll wind up the session. So we'll continue with the next class. Okay, thank you. Well, thank you all.